Good afternoon, everyone. It's a really pleasure to be here, and thank you very much for my host who was actually kind enough to bring me here and also help me to get here from Istanbul because I live in the middle of Istanbul, so I really appreciate the local transportation option as well. So let me introduce myself. I think I know some of you already from previous conferences. I'm Damla Turgut. I'm the professor and chair of computer science department at University of Central Florida. It is actually located in Orlando, Florida. If you heard of Disney parks, we have the biggest Disney parks in the States. There's some in California, but we have bigger ones. So if you have kids or you'll have kids in the future, make sure you bring your kids to Disney parks. Okay. Okay, so basically, although Disney is sort of, for us, locals are the other side of the town. So we are located in the, regular part of the town. And so we are about 32 miles, so it's not really very close. And I'm part of the AI Things Lab. So this is the reason we call this AI Things is because I shared the lab with another colleague who is actually a real AI person who does AI research and robotics and AI, and things like that. And I am more of I'm a networking person. I've been doing networking for 2 decades and more, including my PhD. So, and as you imagine, people who've done ad hoc and sensor networking, naturally moved into IoT, and we do a lot of IoT things. And of course, obviously, we, as a networking person, we actually use AI and machine learning as a tool to solve a networking problem. So we thought, AI things actually really nicely conveys what we do in the lab. So if you have time, I recommend you to go check out our projects that we do in AI Things Lab. So quickly, my research interest. So as I mentioned, I've been doing wireless networking research for many, many years. As I was telling this morning, my dissertation was in actually ad hoc routing protocols and things, right? And then we've done a lot of work in sensor network, ad hoc sensor, vehicular, social, opportunistic networks, and so on and so forth. And then, again, most recently, and when I say most recently, almost, more than almost 10 years now, right? We're looking into, wrong button. We're getting into the Internet of Things, right? So I think this crowd probably knows what Internet of Things, right? Pretty much. So obviously within that domain, we have several different subtopic areas. So these are some of the things that we as a group have worked on. We have looked at the smart homes, smart healthcare, augmented reality, AR, VR type of things. Particularly, we have also contributed to the value of user privacy and mail of information. We have some really nice magazine articles which actually talks about what is the cost of your privacy versus the value that you have gained by actually giving out your privacy. And of course, edge and cloud computing is another thing. And we even actually applied the value of information into edge and cloud computing domain as well. As I mentioned, applications of machine learning in networking AI is actually, as everybody else is doing, this is probably the thing that we do the most. And finally, the last part. This is really interesting, especially when I give this talk to European universities, right? I mean, I'm just as a quick thing, obviously I'm Turkish and I grew up here, all the way to the high school, then went to US. But, as I was growing up, I was never felt like because I'm a lady, I don't, I shouldn't be doing engineering and computer science, right? There was never anything like that. And I don't think there's anything like that here. However, US is a little different. For some reason, the kids in middle school, they start to think, okay, well, if I want to do engineering, that's not for me, maybe if I'm a girl kind of thing, which is really interesting. And so we try very hard to actually bring in middle school kids, high school kids in the universities, and we actually show them, look, you can do this. There's you don't have to be men to do this stuff, right? So this is something that unfortunately is struggle in US, right? We still try to improve the STEM education, encourage them to actually stick with it, right? Because we know that, I'm looking around and I'm very happy to see a lot of females around, and obviously they are just as good. So that's the kind of culture we're trying to bring up in US. And as we have very, very few female faculty members, I always feel like it's my job to make sure that we support women. Okay, Internet of Things, right? So very quickly, so obviously what this is essentially is you have everyday objects that are connected to the internet, but you know, the connection of these objects into the internet has to have some meaning. Just because you connect objects to each other and to internet, it should do something. It should provide hopefully a better functionality, better performance, maybe ease of use and things like that, right? So, but I'm going to, I think the last point is really what I want to start talking about here. Just because the devices are connected to the internet, it just does not really automatically make them more useful, right? And I'm going to actually show you some very quick, fun examples of some of the not so useful things and actually following that some of the dangerous things. Let's see where to begin. This one, what do you think this is doing? You have a water bottle, right? I don't know if you can tell, but this says 50%. So you have an app, right? And then you have a water bottle. It says, okay, how much water do I have, right? 50%. Actually, I think they should have said 52% or something, because then it would be like, oh, this is more accurate. But do you really need this? This is really useful. I mean, it's cute. It's nice. It's a really nice, let's say, undergraduate project, right? But is it so useful, right? This one is actually one of my favorite. It's an eye kettle. I think the thing is a little small, but it is 200 pounds. And what it does is that it allows you to turn on the heating the water remotely. And that's all it does. And because I share my lab with a AI person who does robotics, he told me that I should make this joke, and I think it's nice, is that this is not a robot, right? This does not have legs to go walk itself under the faucet and fill himself with water. You still have to fill the water yourself, right? So all it does is actually just remotely, turn on the water. Nice, but not a must-have. Let me ask this, and usually I get the response that I like. How many of you would like to use something like this? You're not putting your hands up, right? Okay. So this is essentially supposedly for privacy purposes, right? So if you actually block yourself like that, it can actually mean like people cannot read your lips or something, right? So it's a perfect privacy. But again, as you know, computer science and engineering, we are considered geeky people. But even geeky people, I don't think you want to be this geeky or, look like this, right? So this is kind of really funny, but not greatly useful things. Okay, so this is that. But then there are some of those things which are called dangerous things, right? Very scary stuff. Like this one, for instance, hackers can actually make a car wash attack. I mean, you are inside the car, right, when you're getting your car washed. So if they control those, electric things, right, they can drop things on top of the car, and you can actually damage not only the car but yourself. So that's really quite scary. A couple years ago, the Samsung smart fridge exposes the Gmail login details to attackers, right? Again, the smart fridge is essentially the one that tells you, okay, well, you run out of milk, you run out of eggs and whatnot. But they can actually, those people, unfortunately, a lot of those hackers and attackers are brilliant and terribly smart people using their mind to do bad things. They can actually get into your home, right? Infiltrate your home. AccuWeather, right? Code sending user location data even when, as a user, you turn off your location data off, right? So some of those things are, again, very, very scary. And again, Disney suing, spying on children on the several different gamings and so on and so forth. So there's some really, really not great things. Okay, so now we talked a little bit about IoT. So let's see. Now, obviously, we just said that you can have a bunch of devices get connected to each other and connect to internet, getting an IP address and so on and so forth. But does that really make them more useful? I mean, at the end of the day, you use the remote control to warm up the kettle, but what does that kettle do? Makes tea, right? Whether you remote control warmed up the water or you walked yourself and turn it on, it still does the same thing. It doesn't really make it more useful. So really here, networking is really just a means to support the new functionality here. So what I want to also say that when people talk about smart, this is really more of a marketing term, right? It's not really smart. Like for instance, let's talk about smart thermostat, right? So what does a smart thermostat do normally, right? You can say, okay, I want my room temperature to be this temperature to this temperature while I'm at work. And after I get home, maybe make it colder or warmer depending on the season and so on, right? So, but that's not really a smart behavior, right? Right, we are all computer science and electrical engineering and whatnot here, right? So it's really an if-then else statement. If this is the close, do this. If this, and do that, right? So it's really if-then analysis, and it's really like more like rule-based stuff. So it doesn't make it really a smart thing. So what I'm going to say is that you will really need to use an artificial intelligence technologies to make these devices smart or intelligent. And hopefully, through this talk, I will be able to give this point across. Okay, so basically, we can say that in order to be successful for an IoT system, we have to have a network connectivity, certainly. But we also have to have what we just talked about, non-trivial intelligence behavior, not a rule-based system, not an if analysis, right? So what that essentially means is that the system has to take user preferences, user needs, and limitations into account. So what that essentially translates to, depending on user A, needs and limitations will be different than user B, right? And the system needs to make decisions based on your own data. So that's what makes it smart, and that's what we're going to use the AI technologies to do that. Okay, in this paper, we're looking at the smart home environments, right? So this is actually, some of the work has been published in our Infocom paper a couple years ago. So here, let's assume that you have a smart home with lots of sensors and actuators, right? Sensors collecting data about people's lives. So here, the idea is to help users in their daily chores, right? So here, when we talk about smart environment, a lot of times I feel like we really need to think about like assistive environments, right? So how do we assist elderly or disabled users in such a way that hopefully the environment will give them that additional autonomy that they can do things themselves without really 100% depending on the family or professional help, right? But of course, this can also go beyond any typical household as well, right? And again, as I mentioned earlier, one of the important things is that the system needs to understand the human user and then should be able to anticipate the needs and desires of the user. That's when we're going to talk about accuracy, prediction. Is my system able to accurately predict my needs, right? Does it actually able to anticipate my needs properly? Okay. Does anyone recognize these pictures? Come on, you guys should know. You're right next to Britain. I mean, almost. Right? So this is Worcester and Jeeves. I guess I should say my family is a big fan of British TV. So this is Worcester and Jeeves. Worcester is a noble, British man, and Jeeves is his manservant. And Jeeves is like incredibly witty, incredibly educated, incredible person. Let's say, right? He knows everything. So what that means is like when the Worcester goes to dinners and parties and things like that, he knows that the very next day Worcester cannot get up before 10 o'clock, right? He cannot. If anyone comes to knock the door, they cannot see Worcester. And then at 10:05, he has to have his wake up drink, right? And things like that. So those are the needs that Jeeves knows that Worcester needs, right? So think of it. So we wanted something like Jeeves. We want a system who knows the user's needs and then anticipate what needs to happen next. I have one more show to show you, but this is again one of my favorite TV shows. Okay, so assistive environments, right? Monitoring the user and take action basically can actually take actions to help in activities in their daily living. Pressing the wrong thing. Okay, so here basically we're looking at a predictive model, right? So predictive models should anticipate the user's behavior and then use that information to better meet their needs. For instance, this could be several things, right? Like starting the preparation of a meal before the typical meal time. Setting the temperature to the desired temperature for the night. Now, this is a little different than your, if then else statement. For instance, in this case, the system should be able to get data from outside, right? They should be able to say, okay, well, temperature 6 hours from now is supposed to be, I'm not sure if I should say Fahrenheit or Celsius. Let's say it's going to be certain temperature. And then you want to say, okay, and then my, household people leave home at 7 o'clock. Maybe based on that and based on the comforts of the people, I should set the temperature to this. You see what I'm getting at? So you get information from outside, and then you yourself make a decision. As the system makes a decision, what is the best temperature for you, right? Different than you setting up, saying like, I want these temperatures between those hours. I hope everyone is following me, right? Okay. Also, I think this one is also another very important thing, right? Reminding people to take medication. Remember when I talked about users, elderly, and old people, needing help. So, and as you know, a lot of those people actually take multiple medications in a day, right? And if they miss a dose, it can be problematic. So, we want to have some way to make sure that they take their medication on time. And also, not just only taking medication, but also the system should be able to detect changes in behavior by inferring changes in the underlying health condition. Example, so if you have a system that monitors elderly, right? And then you realize that person has been sitting somewhere for the last 7 hours. Okay, that you're probably going to say, what if they're sleeping? No, it's not the sleeping hours, right? What if they are sitting in a chair in their living room for 7 hours, haven't moved an inch? Is that a good thing? Probably not a good thing. It's not a good thing for us either. So we should go up and walk, right? We shouldn't be sitting on the computer all day long. So what that essentially means that they might, maybe you might think, are they hurt maybe? Are they cannot move? Or are they like having depression, right? They're not moving. So you can actually infer some psychological conditions as well. So those are the types of things that we want to look at predicting the user behavior. Okay, so essentially here we want to create a predictive model, right? So how do we do that? We can certainly handcraft a predictive model, right? But it's going to be a little bit problematic because it's going to be very expensive. Just because, humans have particular habits, but they are not going to be, they're not really robust, right? So certainly everybody has certain actions that they do in a day-to-day basis, but in order to create a predictive model, you have to target to individual users, and you can imagine the amount of time that it would take. So as a result, it's not really a great idea to handcraft a predictive model. So then we can say as a solution, we can learn the predictive model from the data that we're collecting, right? And that's actually nice because the recent successes of the ML techniques actually does offer really great solutions in that direction. I'm guessing everyone somewhat knows ImageNet, right? It's a huge data set, right? It has 10 million images, and it actually helped the computer vision to move several, miles to success, right? So those are great things. However, when we talk about smart environment, when we talk about human activity recognition, we are nowhere near that, right? So these are very, very small. And when I say very small, they're in the several dozens of actions a day, small, not millions, right? So then, and obviously as humans, we don't really have much of a patience. We want the model to be functional after a couple of weeks of collecting data, and that's going to be a little difficult. So the point here is that within the smart environment in human recognition, we have what we call data scarcity. Now let's see, how can we potentially solve a data scarcity problem? So one idea is to use the data from users U1, U2, all the way to UN to train the model for user UN plus 1, right? So if you do that, we're going to call it a collaborative learning because you're actually using other people's data to train the model and so that you can the model can predict your behavior. So that's collaborative learning. That's great. And why would the collaborative learning work? It works because, there are similarities between user activity patterns, right? Especially if the data is collected from similar users. And the similar users is really like we're talking about, let's say, people in the living in the assistive home environment, or college students, or let's say even people here, right, in TÜBİTAK who has full-time jobs, also has going to higher education, things like that. So those are specific users. So you're going to have similar patterns, right? So because of that, collaborative learning could work. However, nothing is perfect, right? There's always anything can go wrong. And one of the things is that there's no guarantee that the data is independent and identically distributed. That's probably one of the major problems. And also, using data collected from one household to train another household can also cause problems of privacy, right? And I would say probably privacy is essentially a very, very big thing in US. So people do a lot of things to make sure that their privacy is being maintained. Okay, so let's give us a scenario. And this is my second TV show. This is Hyacinth, and this is the Keeping Up with Appearances show. Hyacinth is a very, very peculiar lady. She knows what she wants. She has incredibly strict, detailed rules, house rules. So the reason I put Hyacinth here is that can your system can someone like Hyacinth be able to use the collaborative learning, right? So this is almost like an outlier in some ways, right? So how can Hyacinth use the collaborative learning for it to work for her household? But watch out, it doesn't always work, right? All right, so let's say Hyacinth wants to install a smart home assistive system. I call this British household helper because, it just fits the bill here, right? And then let's say that this was installed in February and this was the 100th system. So that means there were 99 systems in place, which means that you can actually collect data from 99 previous systems, right? So Hyacinth starts using the system, but the decisions made by the system do not seem to quite help Hyacinth. You can kind of tell why, right? Because Hyacinth's, preferences and rules are very, very different. So it doesn't seem to follow her preferences. It doesn't anticipate the needs. It offers actions that are incompatible with the house rules. So then Hyacinth obviously is not very pleased. So it calls up the company and says, okay, well, this is not working for me. Please give me some solutions, right? So then they give her a couple of options. They said, okay, well, you can certainly continue using the system, and eventually it's going to learn all aspects of the household lifestyle, right? And what we call this one a local learning. So you're learning from your own behavior, right? So when it comes to accuracy, you can imagine that the accuracy of a local learning is going to be better. Why? Because you're learning from your own actions. You're not learning from the actions of the others. However, every day, you're going to collect data one day at a time, right? So it's going to be very slow. So the system will not be trained very quickly. Okay, but on the other hand, can anyone tell me what does that mean for privacy? When you have a local training, you're not sharing anything with anyone, so your privacy is essentially more or less maintained, right? So you're not really sharing anything. So obviously these are trade-offs, right? So then another option is that you can share your details of your data routine, and we call this decentralized learning. So this would allow the system to train a model using both Hyacinth's own data and the data of the other 99 users. So imagine your data, your model is going to be trained much, much faster, right? So your data set will grow 100 days worth a day versus 1 day, right? You can see that. But again, when it comes to privacy, the things flip, right? So here you're sharing your data, so your privacy is actually pretty much, I wouldn't say gone, but it's definitely not the same, right? So it's going to be cut. So the problem there's a privacy, problem of privacy. So here's Hyacinth and her husband doing some funny business. So Hyacinth thinks about all of that and says, okay, well, basically she says, I'm not sure about, centralized system, but also I'm too impatient to make the system work too, I want the system work quickly. So she asked for a different option. So then they said, okay, fine. You don't like local, you don't like centralized. How about we give you somewhere in between, right? And we call this a federated learning. Federated learning is actually a type of collaborative learning, right? You're still actually using the data from the previous household. However, what the difference here is that you're not really sharing the actual data with the centralized unit, right? You're sharing the parameters only. So when you're sharing the parameters only, you are actually putting a layer of privacy on top, right? And we will see that in the results that the performance of the federated learning and centralized learning is actually very, very similar to each other. Maybe centralized learning is a little bit more, but then when it comes to a privacy aspect, federated learning will be better, right? Okay, so basically, so these are some of my things about, Hyacinth's rules, right? He makes the repairman take their shoes and stuff. I mean, it's not as funny because, this is what we do here, but it is really funny in UK, people don't do that. So as I said, this is really very specific rules that Hyacinth actually requires in her household. Okay, so just very quickly summarizing the training strategies. So with the local training, you have the highest level of privacy, right? Obviously, you don't have to share your data with anyone whatsoever. So everything, and you are actually learning from your own data. So you're learning one day at a time. Centralized learning, you actually use data from other people. So you share the data with everyone. And so you do learning much, much faster. Obviously, the privacy is probably, the privacy loss, I would say, the biggest in centralized. So with the federated learning is a method in between where you have the same, you're taking advantage of the previous household data, but as you can see here, we are actually only sharing the client parameters instead of the actual data, and that gives us that additional privacy aspect. But if any of you read papers or done work with federated learning, you will also know that federated learning is not also guarantee you 100% privacy, right? In fact, the professor, security professor in Purdue, Spaff, Professor Spaff always says, I remember him coming to us one time and said, as soon as you walk yourself out of your apartment, your house, your privacy is gone, right? He always says, there's never 100% privacy. However, having said that, you could use certain things to ensure that your privacy, you can somewhat control the things that can go out, right? So federated learning can also have some privacy leakage. Especially people can take a look at the data and temporal aspects of the data, and they can make some deduction and they can actually figure certain things out. But if you were to just comparing federated versus centralized, you will see that the federated is going to actually have a better better privacy option. Okay, what are some of the research questions? So basically we wanted to see, okay, so what kind of machine learning techniques can we use to predict the human behavior, and how can we validate them, right? And what performance differences exist between different techniques? So for instance, are we willing to lose some performance measures, right, in order to increase privacy, right? And the answer to that is really, there's no really perfect answer, right? Or there's no right or wrong answer because it depends on the person. Someone might say, I don't really care about my privacy. I want the highest possible performance, right? So then, maybe centralized learning is the best one for you, right? But if someone says, I'm willing to give up some level of performance, but I really want to keep my privacy intact, so then federated learning would be the one. Or if someone says, I don't want privacy loss whatsoever, I have all the patience in the world, then local learning is your friend, right? So that question really depends on the user, right? Also the question, does the performance depend on the peculiarities of the given household? I would say probably yes, a little bit, right? Because if you have a very peculiar household, then it's just going to take harder. It's going to be harder for the system to reach to a level of accurate results. So we basically used LSTM model for our machine learning. This is how it looks. I'm not gonna get into details, but so training and validating data. So here we actually used a real world data set offered by CASA's project. So this is a adaptive systems lab at Washington State University. And this is a publicly available data set. So they actually had people, they've actually collected data, people living in houses, and about their daily activities. So this is a real world data set, which makes it great because, as you know, like if you don't have a real world data set, if you have like a simulation data, it's not going to be the same thing, right? But you can certainly do maybe create potentially synthetic data based on your your real world data. And we have actually done that with our projects with one of my previous students with the mobility patterns and in Disney parks, for instance. So here we have basically data sets being collected subsistence of the stay in a single home. So here we are interested in modeling situations where the BH3 system is deployed simultaneously. So what that means is that we are interested in so the reason we don't want everybody to start at the same time is because not everybody will be able to have the opportunity to start because of the needs for the hardware, software, and things like that. So it doesn't really make sense for everybody to start at the same time. But so here you have essentially 30 homes, right? So you have the days, right, January through April. So if you have a discrete point in time, right, January 16, so for instance, the house number 3, 6, 11, 12, those are actually the ones on the red are the ones who started early. So for instance, when we, let's say house 21. When the house 21 starts, it's basically going to have a data from all the houses that it started before that, right? But if everybody else actually starts at the same time, you don't really, the federated and centralized won't make a difference, right? Because you don't really have anything else. So that's why it makes more sense to do it like that. And because of that, basically we say that it actually really follows the Poisson arrival process. Okay, so how do we measure the performance, right? So obviously here our performance metric is really measured by the accuracy in activity prediction. How accurately can we predict our activities, right? So here, as you notice, we have looked at local training, centralized and federated. These are part of the collaborative training model. So let's remember with the local training, we get actually 1 day of data. So we are not really gaining a lot of data, but with the centralized and federated, we take advantage of the previous data. However, as the time actually goes on, you will notice that every single of these strategies are going to get better and better. But what's interesting, I won't give this away now, but at some point it's going to look a little different. So now what we're going to, we not only want to look at the performance, we also want to look at privacy, right? So with the privacy, we know that the local learning will, the one that has the highest privacy, federated is going to be better than centralized. But again, as I mentioned, there are some loopholes can still happen that you could lose some further privacy there. And then we have also created, the concept called regret. So this is the benefit we could get if we use collaborative learning instead of a local learning since the deployment time. So what this means is that if you had actually used if you didn't use the right technology, the right techniques at the beginning, that you are going to get this area that we call regret. Okay, so this is the different data collection duration, crossover point, and regret for several of the houses. And I'm going to actually go to the next slide and dig into a little bit more one of the houses, and then we're going to go and look at some of the others. So here, quickly, the y-axis actually talks about the accuracy, right? The higher the better, right? So, and these are the days. So this is house number 2. It started, let's say, day 22 or something like this, right? So take a look at the purple line, right? So this is the local learning, as opposed to orange and blue line, which is the federated and centralized learning. So what can you tell, right? Federated and local actually has twice the performance at the beginning, right? Which is fine, because obviously federated and centralized learning actually have data from other houses, so they can actually have much better prediction. So it's more than okay, as expected. However, as the days go by, there comes to a point where we have this triangle. We call this a crossover point. This is the point where you are going to say that your local learning is going to actually take over the other learning, other collaborative learning opportunities. At this point, you as a user have the opportunity to say, I am no longer interested in participating in collaborative learning, but I'm going to actually continue to use my local learning, right? And the regret is this area. So what this means is that probably I should have started with federated or centralized at the beginning, right? Because if I had, I would have had a better accuracy at the beginning. So that's the area of the regret. Okay, so going back to this one. So you can see every house actually starts in a different place, right? House 1 starts in something like 45 day, and this was 22. This was actually very early, and in fact, this is very interesting, right? House number 3, this one right here. So we don't really have a regret, right? Why do you think there is no regret? I want to say maybe this is like day 3, 4, something like that. The reason there's no regret is because, and there's also the reason that really there's not much of a difference with some of these things is that, you know, for instance, these two, right? The purple is actually the local learning. There's no differences because there's really no other houses probably were available to get the data for the federated learning or for the centralized learning to take advantage. And that's why the regret is 0 here. This one is interesting. We never could figure out why there is no crossover point. There was never a point where the local learning took over. So that's a strange case. But like for instance here, there's like a very, very tiny regret here. And again, some of the places there's no regret, and this is very similar to this one. So this is actually shows you, depending on the different houses and different mobility, different activity patterns, you would have a different type of, different places where you have the crossover and a different type of, different level of regret. Okay, so from these results, we can say that all the approaches improve with additional training data. I think that makes sense, right? As the time was going on, everybody was getting better. Clearly, local learning starts the worst because they are only having one day of data, right? And but as usually they end up to be the best, right? Because of the fact that you're actually learning from your own data, so ultimately the accuracy is going to be higher. Federated learning generally is a tiny bit behind the centralized learning, as you've seen. However, that tiny bit behind is really tiny, right? It's not really that much. And that's what I was saying. Like, for instance, if you're really big on privacy, you could lose just a tiny bit of accuracy, but you can actually gain on the privacy. And crossover point is the one that when the local learning is essentially is the best approach to take, right? Okay, how to find optimal privacy and performance trade-off, right? So in that case, we can say, well, there is no benefit for ISN to participate in either centralized or federated after the crossover point, right? So it's just, I mean, she could if she wants to continue being a good citizen, but why would you want to do that? Because it actually comes with some, some privacy loss. So the optimal strategy for her should be then we should use federated, not centralized, right? Because centralized is a tiny bit better in performance, but lower on accurate privacy in the early days of the deployment, and then basically you stop sharing your data once you have the crossover point. So now the question comes, would there be any benefit from collaborative learning, right? So you notice that location of the crossover point is quite different in every house, right? And so the reason for that is obviously the daily routine of the users are, if your daily routine is different than your peers, then crossover is going to be very early, right? Because it's just not makes sense that way. However, no benefit from the collaborative learning. So another thing I want to point out here, the first day problem. So what this is saying, like really the highest level of privacy happens in the first couple of days, right? So if you share your single day of activity, it's going to be the highest level of privacy loss. Which means, like for instance, if I share my activity, what I do on Monday, and I'm a full-time employee of somewhere, right? So what are the chances that I'm doing the same thing Monday through Friday? Quite high, right? So essentially sharing your one day's activity is going to be actually give you the largest loss. So in that case, can we really predict the future performance of federated learning for any given node without joining the pool? So that's interesting, right? Can we actually make that decision? So what we did was basically we said, okay, here's our hypothesis. We said the proportion of the activities in the home for the first days will say contains sufficient information for us to be able to predict the performance of the predictor. And then we essentially trained a classifier and we put essentially the activities of the users in the first 2 days. I see it sounds coming here. The output is actually, it's not showing here, but it's a Boolean thing. It's going to be benefit or no benefit. If it's beneficial, then go ahead and join the pool. If it's not beneficial, don't join the pool. That's what's missing down there. Okay, so then you have this home too, right? So we talked about the human, the activities and routines. And this is essentially that, right? So here you have the personal health and hygiene. So this is essentially, I guess, taking showers and whatnot, relaxation, leaving your home, entering your home, right? Leaving for work, coming back. Some of the household chores, eating, socializing, drinking, resting, right? So these are going to be also vary from household to household, right? For people who work full-time, have kids and goes to school, probably doesn't have much of a social life, mostly work, right? Whereas if you're a full-time college student, mostly you can balance things out, right? So it's going to differ from place to place. So this is how the variations goes from different households, right? So same idea here, the same thing, it's different from different households. Okay, so I really don't know what time it is because I didn't put my time, but I think it's getting close. I'm almost done. Okay, so how can we accurately predict whether there will be any benefit? Remember, we said that we have trained some classifiers. So we have actually tried decision tree, SPM, nearest neighbor, and random forest. And as you see, the F1 scores are, the higher the F1 scores, the better, right? Because that actually shows reflects accuracy. And the nearest neighbors is actually gives us the highest level of accuracy with the 0.77. And obviously, K-equal to like your nearest neighbor is going to give you is closest to you, right? So that's why it actually somehow it does make sense in terms of like learning from that group of people and to predict your own behavior and so on. So let's see. Right. So basically, I think I already mentioned that the similarity profile is already in the pool. Performance is sufficient to make a decision, and you can basically say, okay, if this is the case, then I am going to go ahead and join the pool. Or if you think that it's not sufficiently beneficial, then you can actually refrain yourself from joining the pool. Okay, so conclusion. Human activity prediction is important, right? And we can certainly combine different, combine training data from multiple, from multiple users, and we can actually improve the accuracy greatly, especially in the early phases of the development, right? Because in the early phases, if we do local learning, we are again getting one data at a, data from one person and then one data at a time. However, if you were to get from multiple users, obviously, as in the case of collaborative learning, we know that the privacy issues can happen. So what this essentially tells us, the privacy of the users must be weighted against the advantage offered by cloud-based collaborative learning techniques, right? So again, are you willing to give out some performance in order to get more privacy, or would you rather have your, keep your privacy at highest level as possible? So depending on that, you could go for local, centralized, or federated setting, right? Okay, so basically we also said that the greater privacy of the federated learning would actually be more preferred model. And as we notice that the local training eventually overtakes. And so at that point where the crossover happens, local training always gives us the better accuracy, right? And finally, we, as I showed earlier, we train a classifier that can predict the crossover based on only the first 2 days of the data with no disclosure of the information. And with that, I think that ends my talk. I think I'm a little over time, but I think it's okay. I'm done. Holding pattern.